Thank you to all our attendees for being here today with us. A lot of people from east to west. Thank you for participating. We have a session dedicated to the SIL 3 safety instrumentation, explosive environments. I want to just say I like this point with you that is not say safety functional safety courses. We are not giving details about how to create a SIL loop or whatever is necessary. We just give an overview about the application. So be patient on what we say to you. Maybe we got a lot of questions during your registration session. So of course, we can answer by email later through our technician, our people. These are interesting, and of course, they deserve an answer. But we cannot answer to this specific question regarding functional safety during this webinar. It's just to give an indication what the market is requiring. Okay. Okay, so we are today. Let me start. I see that people are already here a lot. Thank you for being here. We want to just say inform you that the chat box is available. Sorry, chat is not available. You just push a Q&A button and you're gonna say send in a message to us, and we try to answer during this webinar. Okay, I'll leave the speech to Gabriele.
Okay, thank you and welcome, and thank you for being here. So just a quick introduction about myself. I'm Gabriele Caglio. I'm the technical support specialist at GMI, and Andrea is here with me today, which is the global account manager. I'm gonna do a brief introduction of GMI for whom doesn't know us. GMI is an Italian company providing field interfaces related to intrinsic safety and functional safety. This means that it's possible to find GMI devices in many industrial packages, such as DCS, ESD, fire and gas, and so on. As you can see from the screen, we are talking about oil and gas, petrochemical, pharmaceutical, mining, but also food and beverage, and many other industries. Next. We have several offices and resellers all around the globe, so we are pretty much available everywhere and close to our customer. Next, thank you. We have 40 years of experience in the field. The headquarters is in Italy, where we have our main facility and where we design, produce, and test all of our devices. As I mentioned before, we are a safety company and we aim to provide safety and reduce the risk of hazardous events, people, assets, infrastructure, production, processes, and the environment too. For this reason, the quality aspect of our product cannot be overlooked. We design our product, we manufacture and test them 100% internally, meaning that we do not outsource any of these tests. This is why we are confident about the quality of our products.
Gabriele, just one point. There is one attendee. It is say that is not getting audio. Can you please confirm via say Q&A in writing if you?
There is anybody else? Not
yeah, because for us, how it's okay. We don't see any problem.
Fine.
Maybe it's just the PC of this attendee. All the other are hearing very well. Please confirm. Okay, I don't see any further. Please go ahead, Gabriele, in the meantime.
Okay, let's go to the next slide, where we can have a quick slide before to get to the real part of the webinar. One is this one, and is about the certificates we have, or at least the certification bodies that we are dealing with. This guarantees the quality of the devices, but also guarantees that GMI products comply with the market requirement according to the different local regulations. The next slide is a brief overview of our portfolio. As I mentioned, we have intrinsically safe barriers, we have safety relays, SIL certified, with and without line monitoring for energized to safe or de-energized to safe applications. We have isolators, we have AX power supply systems up to SIL 3, temperature and digital multiplexer for zone 1 installation. We then have termination boards for an easy connection to the main PLC and DCS systems. We have heart multiplexers, surge arresters. We also provide consultancy and share our experience through courses related to functional safety and intrinsic safety.
Okay, all the other attendees confirm that audio is okay. So
it's okay. Okay.
kindly ask to check if you are not hearing the volume and not the audio, please check on the setting of your PC. Okay, so
okay.
Yeah.
This final slide before to get into the webinar is about some of our customer, and this is a list that stretch from system vendors to EPC, OEM, and end user. Before to start, the last thing is the webinar is going to be recorded. In a few days, you will find it available on YouTube, our YouTube channel. So if you want to get the notification, you can also subscribe there. You will get a link to download a copy of this presentation, and you will also get a certificate, but only if you attend at least 75% of the webinar. If you have, as Andrea said, if you have any questions during the presentation, please write them down in the Q&A so we can answer you. I see that someone is...
So we can skip at this moment the poll because it's not ready, so we go directly to the safety relays part. Please, Gabriele, go ahead.
Yes. Yeah, I just see someone is asking if you supply this product to India as well. Yeah, maybe Andrea, you can give you, yeah, we have an office there, maybe Andrea.
Okay, yeah, we can deliver all over the world, India included.
Sorry. So the first concept that we need to introduce today is the concept of safety instrumented system, which we'll refer as SIS. What is it? It is a set of subsystems that makes the safety loop. Within the safety loop, we have field devices such as transmitters or sensors, which allow us to control, detect, and measure different variables in the field, such as temperature, pressure, or any other. These variables, from and to the final element, passing through barriers and relays, are managed and interpreted by what is the brain of the SIS, which is the PLC or the DCS system, which decide what kind of action are necessary to make and maintain the plant in a safe state. Power interfaces, such safety relays, act on valves, sounders, beacon, and other actuators, and allow us, in case it is required, to drive the system into a safe state. The important thing to note here is that every single element of the SIS must be sized accordingly to the required SIL level to achieve the tolerable risk level. All the components within what is called the safety instrumented function, or SIF, including power supplies, are safety related, so they must be SIL rated. And this is what makes a loop safe. Let's go to the next. Let's examine now a safety relay as part of a safety instrumented function. A safety relay can stop or initiate a movement in a controlled manner. This means that it can open or close a valve, start or stop a motor. Such devices must conform and adhere to the IEC 61508 industry standard. Safety relay shall be used where a failure of the device can cause serious accidents to human assets, infrastructure, equipment, and the environment too. This is not only strictly related to the oil and gas or the process industry. This is valid as a general rule. Typically, safety relay is used in all those applications where the controller, which is usually a digital output card of a PLC, is unable to activate a field device due to its limited potential in relation to the voltage and the currents involved. In other cases, it is possible that for managing the simultaneously activate multiple loads, a set of multiple contacts is necessary. Some other scenarios, safety relays are involved when the safety function that the controller must be inverted. Furthermore, in case of smart relays, which is the most complete version, we can extend the diagnostic capability of the safety system to the entire loop. introducing the predictive diagnostic concept, which is extremely useful, especially when we talk about fire and gas. Let's go to the next.
So there was a question, Gabriele, here, attendee say, do you have electrical conductors certified by IEC 61508 that you already answered here? Yes. So we are dealing with this product and not only with this product to IEC 61508. Okay, please go ahead.
Yeah, this is for you. It's a question for you. Which are the differences between a standard relay and a safety relay?
Yeah, of course, that is in the market. There are a lot of relays. You may find different application, different solution, but most of them are standard. They are not safe. So a SIL certified relay is a relay that, as is written, is no warranty ability to perform a given safety function. So basically, it's a really basic product, but is safe. So when you ask to move and to open or close, there is a really high probability that this safety function will be performed. Okay, so safety function is the ability to reach a safe state on demand. Basically, it's very simple. So open or close a valve or start or stop a motor. Those are the main function where the safety relay is used. So most of the time is the solution is normally energized. In case of emergency, you wanna open. So de-energize to safety is a function. That is called ESD, IPS, BMS application like emergency shutdown systems mainly is the focus for this function. The other way around, you have a fire gas application where the safety function is normally de-energized, so the contact is open. You want energized to safety, so the application is closed on demand. That is the application. Those are main application for a safety relay, and that's you clearly understand that you cannot use for such application a standard relay. Okay, so indeed, but there are few, let's say, things to keep in mind. So for determining a SIL level of components of a system of a modules like our relays, they have to, of course, evaluate the FMEDA for each component. So you see a table, just an example table where you have different components. So inside the component, the module, there are 150 components, electrical components. All of them have need this, say, the calculation, the values given by the manufacturer for the failure. So there are failure rate is called lambda safe and lambda dangerous. So safe failure and dangerous failure. Those are the main things. So for each of them, there are safe failure, and it's called detected failure and undetected failure. So there are safe that can be detected, it can be undetected, but those are safe. There are dangerous that those can be detected, and in that case you can do something, and other that can be undetected. And those are the most complicated because are dangerous and are undetected. And is very, very difficult, of course, to predict that the SIL product have to reduce as much as possible those values of dangerous undetected failures. Okay. So, Gabriele?
Yes, we can start taking a look now at some example of real life applications starting from digital input. Let's see, digital input devices are those devices capable of managing a voltage-free contact in the field and typically communicate the status of this contact to a digital input card.
Sorry, Gabriele, there is a question related to the previous slide that is better to explain now. The question is, how is the calculation done for dangerous undetected failure? That is a good question. So if you remember, let me go back so we can have an interactive presentation. There are different components, and for each component, there are then at least there are all you see the safe D means in this, let me highlight so people can see what I'm telling them. So there is here the SD is a safe detected, SU is safe undetected, DU is dangerous undetected, safe U is a safe undetected. So basically, for each component, it can be a resistor, can be capacitor. There are say this value supplied by the manufacturer. So all, let's say, the addition, the calculation of all these dangerous detected values are, say, results in a value, danger undetected value that is valid for the component, for the relay in this case. So basically, is calculated on all components. Just to hope I have answered to the question from the attendees. Please go ahead, Gabriel, again. Sorry.
So we were making a classic example where a more proximity sensor, for example, which status is acquired by a galvanic isolator and is sent to the system. In case we have or we need a web contact in the field, we then have 24, 48, 230 volts. Then we shall use a relay, which is a device that, depending on the voltage available at its coil, yes, activates or deactivates an output and communicates such status to a PLC or a DCS. In the next slide, we have this example that could be the one where we need to put into communication a PLC, two PLC systems placed into different contexts. In this different context, the digital output card of one of the two systems controls our relay, while a digital input card acquires the status of the contact. The main problem in this case is that usually a relay is designed to switch important values of current, while a digital input card usually manage currents lower than 100 milliamps. In this situation, we can face problems of oxidation of the relay contact. Therefore, it is essential to choose a safety relay with gold-plated contact, which allows us to switch currents lower than 10 milliamps. In the next slide, we can see that GMI designed a solution to deal with this issue by equipping all our safety relays with gold-plated contacts, so they can be used also for this type of application. In addition, GMI has developed a universal device able to receive at its input different voltage levels with a voltage-free output, compatible with all the PLC and DCS systems, so we can ensure the conductivity even at lower current. Next, yes, smart relays allow us to monitor constantly the load on the line and report to our system if a fault in the field is detected. The diagnostic of this relay is active both when the relay is in on and off condition, so we can monitor the health of the entire loop. And as we mentioned before, this figure is extremely important when we talk about fire and gas applications. Why we should use a smart relay? Nowadays, a full diagnostic of the loop is typically required, but many systems do not have this feature within their digital output card. So in this case, the smart relay is what introduces the diagnostic. In some other cases, the systems have their own diagnostic, but in many applications, they cannot drive the load directly because of their current and voltage limitation. If we consider loads such as valves, sounders, speakers, they usually need more than 500 milliamps at 24 volts, which is usually what the digital output card can provide. In this case, the introduction of a safety relay in the loop allows us to drive the load and extend also the diagnostic capability of the system. We also must mention that in some other cases, the diagnostic of the digital output card is limited, and for instance, earth leakage may not be detected, or extreme load such as beacons may always be seen as an open circuit, which is an issue that can be overcome by using a safety relay. So As I just said, a safety relay can introduce the diagnostic feature when it's not present, extend it or enhance it when already available on a digital output card. See the next slide. Okay, smart relays also introduce the possibility of mirroring a fault in the field to a digital output monitor card. This function reflects the fault condition acquired in the field directly to the supervised VIO card of the PLC. In off state, through a pulse test system, and in on state by reading the static return of current. The digital output card can acknowledge the fault in this way. This communication happens through a variation of impedance that occurs at the relay input terminals. This type of solution can save, of course, engineering cost, wiring cost, because otherwise we should use an additional digital input card to acquire a fault condition. So GMI, in our range, there are two models, these two among others, which are the D5096S and D5096S-100. Let's see them both. The first one, D5096, is a smart relay with a fixed diagnostic range, which mirrors a fault in the field directly to a digital output card, compatible, of course, with this functionality. This type of relay is SIL3, and it's suitable for both normally energized and normally de-energized application. As I said before, the mirroring function is performed through a variation of impedance, but since not all the PLC are able to read such variation, we design a second model, which is the D5096S-100, which has the same diagnostic function, but it is used as a universal mirroring system compatible with all the PLC cards. That's why inside the relay in series with the input circuit, there is a transistor, which when a fault is detected, it opens, and therefore the digital output card can see this open circuit. This type of relay is SIL3 for normally energized application, but it's just SIL2 for normally de-energized application. In the other slide, we can see the two. Yes, we can see what we can monitor when the load is active, so the relay contacts are closed, and we can monitor the voltage applied to the load and the current flowing through the load. In the next slide, we can see that the load is not active, so the relay contacts are open, and in this condition, we can monitor the power supply voltage and the load resistance. Another model that we have right here is called the 5294S, which is, again, a smart relay with fully configurable diagnostics. So instead of having a fixed range, as we saw in the two items before, here there is the possibility to set a diagnostic range according to the application and the load involved. This device has also an internal diagnostic and the possibility to diagnose a leakage between load and earth, and to read and write data via Modbus. Might be interesting for a second to mention why Modbus communication feature might be interesting. The Modbus can be arranged, for example, in a multi-drop network up to 127 modules. So all of these modules in the network can be monitored and configured by a single master unit. Each slave contains a set of parameters. Each of them is univocally identified through an address and makes these values available for reading and writing anytime it's required. This means that through a single bus, all the smart relays can be managed and communicate with the system. Also, in this case, the use of a dedicated digital input card to acquire the fault can be avoided. So with this solution, it's possible to have in one place load management, diagnostic, real-time information from the field, and the remote control of the relay. The next slide, we see again the two different conditions. So in case of normally energized load, it's possible to monitor the voltage applied to the load, the current flowing through the load, and the internal coil integrity. In the second case, which is the opposite, and it's a classic fire and gas application, where the health of the load and the load must be monitored to be sure that in case of emergency, the load is capable of operating. In this case, we can monitor, again, the power supply voltage, the load resistance, and the leakage from the load to the ground. in the next slide, we can see just that the D5294 is total configurable. So this kind of smart relay can be configured in case the parameters that shall be monitored are specific and the acquisition on the fault cannot be achieved without the standard monitor relay. Through Modbus or a dedicated software, we can completely configure the module and monitor the health of the loop in real time. We can, for example, set up a window with high and low thresholds for voltage, current, impedance with the load. Within the load typically works. So when one of these thresholds is exceeded, a fault is going to be, of course, issued to the system. These are the advantages that this type of smart relays can offer. Just to set an example, where a single digital output driver should deal with a dual coil valve, we know that even in case one of the two coils is damaged, the valve can operate. But in this context, the D5294S can detect such condition and provide this information to the operator, so the proper action can be taken in advance. As we have seen, a smart relay can report the field status to the system in different ways. So the fault condition can be acquired through a dedicated digital input card using the relay fault output. The fault can be mirrored from the field to the system and acquired directly from the digital output card, of course, as I said, if it has this feature. A cumulative fault on the bus network can also be acquired by an additional digital input card. And a full set of diagnostic data can be acquired through Modbus, and the relay can provide real-time information, and it can also, as I said, be configured.
Yeah, I want to just highlight one point, Gabriele. If
Yes,
you
please.
coming back to dangerous undetected failure, that was the question before. The line monitoring, in this case for the relay, give you the possibility to let's say detect some values like current or resistance or voltage that are realize that cause a fault on your application. And in this case, if you can monitor them, you can detect it and you can alert your say system, and you can do something, of course. So I would say that in this case, those failures could be dangerous. And if you don't detect it because you don't use line monitoring, those are undetected. So those are dangerous undetected. But if you are able to monitor them, you can detect it. So in this case, they became dangerous but detected failure. So they change completely the safety value of your system. Okay, thank you, Pilman. Go ahead.
Okay. Yes, few things, few more details about the mirroring functionality of a smart relay. This function, as I said, allow us to reflect the information from the field directly to the supervised digital output card of our PLC, both in off state through the pass test system and in the on state by reading the static return of current. The DO card of a PLC system can detect this information and relate it to a fault. These operations are based on this variation of impedance of the relay input circuit, which can be acquired and interpreted as a fault condition only by supervised digital output card. Let's define in the next slide a couple of words. So safety means the demand for functional safety, SIL, based on IEC 61500-08 and IEC 61511, the safety standard for the process industry. A device can be considered safe if able to perform a certain function when it is required. When we talk about availability, we are defining the proportion of time for which the equipment is able to perform its function. Availability is different from reliability because the latter takes into account the repair time. For example, a device may not be very reliable, but it can be repaired quickly when it fails, and so its availability can be very high. Few more slides, let's go to the next. So we can see another real life example, and something that we can call an issue, but and how to overcome it. So here we have an example of a sounder. Typically, these devices, especially in the off condition of the relay, show to the relay a very high impedance, often outside the diagnostic range of the smart relay. On the opposite condition, when it's on, they show a very short, for a very short instant, a fault condition due to the capacity front end that they have. These problems often occur with this type of field devices, and to overcome them, it's necessary to insert a resistor, so-called end-of-line resistor, in parallel to the device itself, which allows us to bring the impedance values of the field device within the diagnostic range of the relay. Another important thing to know in the next slide is that due to the strong inductive or capacitive front end of the load, it is possible that there are strong reverse current peaks, which may damage the relay contact. To overcome this problem is again necessary to insert another device, another protection, such as a PSC, a PTC, sorry, or a power resistor, able to dampen these dangerous peaks. And in the final schematic, in the next slide, we can see how and where these additional components are usually placed. So the end-of-line resistor must be necessarily placed in parallel and as close as possible to the terminals of the field device, when the protection shall be placed as close as possible to the relay contacts. In the next slide, there is another type, or at least two types of application, two different way of wiring a safety relay. So it can be connected in a unipolar or bipolar configuration. The bipolar connection allows a complete isolation of the load. And this is the most recommended, especially in the application where the load must be powered with high voltage. From an electrical point of view, this type of connection grants a great safety thanks to the complete isolation of the load. A unipolar connection isolates the load only on one of the two power supply lines, and this connection is the one that usually saves more cable and wiring cost. In case, we can see the next slide, that in case the load is going to be wired in a unipolar configuration, but it is also required that the loop and the load is monitored, the correct device is the D5294S. As we know, the bipolar connection is the ideal configuration for an optimal functioning of the relay diagnostic. However, the D5294S guarantees in a reduced way a diagnostic of the field device connected in a unipolar mode. It has to be set to work in this scenario, of course, and we need to know that in on state, it will be capable to monitor the current circulating in the load, while in off state, we will be able to monitor the power supply voltage of the load. Please, Andrea.
Okay.
Go ahead.
So we have now a poll. I'd like you try to answer and with your comments on this. Can you see? I think you see that if you want to, of course, what the safety relays feature do you consider as relevant? So like pass test compatibility, alarm contact out, Modbus interface, configurable threshold, and fault mirroring on the card. So this is pretty new technology. So the line monitor relays new solution in the market. But we see that in project people asking more and more for having this topology relay, because the thing is when you use external relays, the relays say you drive the coil, you close or you open the relay, external relay, but you never know if your load is activated as you wish. So the line monitor gives you these extra features and for the relays, and you can detect what is really dangerous undetected can become dangerous detected failure that enhance your SIL level. Okay, thank you for answering. I think I see a lot of answer on this point. We can close now, and maybe you can also show to the people the results. So the result is that the winner is fault mirror on the card. So this is a special feature. No people needs a configurable threshold and alarm contact out to pass test compatibility in both bus interface. We do remind the configurable threshold is something that can be applied when you have a specific load and this load gives an impedance very high, and so some firing gas application, especially we see that there is a demand for the configurable threshold. Okay, thank you. We try to go ahead with the next slides.
Yeah, we have a couple of questions related to the relays. Maybe we can answer them before to move to the next topic.
Yeah. What will be, so the rule for user line monitor for DU failures. So this is something that we can say if there is a really rule in 61511 norms regarding the user line monitoring for DU failures. I'm not sure if there is something, but we can check for it. So what is the application of SIF to relay in a typical instrumented system loop? What is the application of SIF to relay? I would say that is safety instrument. I would say it's when you have a safety valve, that is the most say known application for ESD, or maybe you have some lamp or some light or whatever, some horn that you wanna say activate in case of alarm. Okay, so do you have any say suggestion, Gabriella, about this question or not?
No, that's the sense. The system, the relay, and the actuator in the field, which can be, as Andres said, the valve that needs to be activated in case of emergency, a sound or a beacon to notify that some hazardous event is going on, but that's the typical application, yes.
Okay, so there is another question. So before we go ahead, how is the SIL assessment conducted for particular instruments, especially during selection? That is a good question. We cannot really answer because we remind you so we say that we also arrange some SIL courses that can be some webinars, so it can be functional safety course. In that case, you gonna have all details about that because it's very, of course, complicated and cannot be answered in such a short time. Sorry for that.
Yeah, what we have a page on our website where all the webinars are listed. So you're probably gonna find that in 1 or 2 weeks we are gonna have a webinar about these topics. So you can.
Not sure if you can answer that question during the webinar, but anyhow, you can get at least some more details.
Some insight, yes.
Okay, so now is my turn. I would like to say give you more details about isolators and line monitoring, especially because this is the features because is really there is a high demand on that. So processor connectivity. So you can have a solution with for all signals. You wanna that basically in hazardous area you wanna connect to the safe area via PLC or via DCS. So we have a broad range with different features, with different SIL level as well, for mounting in safe area on zone 2 for connection up to zone 0, so the most dangerous areas. So basically, the line fault detection in analog input is really intrinsic because for the more complex transmitters, the limit can be 3.8 milliamps as the lowest and 21 milliamps the highest. So in that case, our transmitter, our modules, transmitted a 4 to 20 milliamp signal transparently. So they are not, say, limits at the signal at 4 or 20. So they have a broad range and they can, here you can get easily the information about the fault on the field. For analog output, there is a possibility of having a contact out when there is a load resistance higher than 4.9 ohm at 4 milliamps. So So, and also the thing is you can have high impedance and reflected to the control system. That is another feature that the unit is giving. So you can either have the fault mirroring or a free voltage contact. We do have also the digital signal. So if you have a proximity or a contact, we have some solution that can be either C3, C2, C3 compliant with this kind of resistance on the output that give you this value of resistance in case of fault. So there is so you can detect switch open or close, or open circuit or short circuit. So all in this case, you can detect this kind of fault. Otherwise, if you use a normal interface, just detect open contact, closed contact. But this, I don't go in details because it is not the purpose of the meeting today or the webinar. But this resistance level give you the exactly information about the fault of the input circuit. It can be short open circuit. We have also some devices that are specific for DCS or for PLC. Basically, that is a request for PLC because DCS don't have such kind of monitoring functionality. But we have a solution for Triton systems, for Honeywell systems, for Emerson, for Yokogawa. So all those people, PLCs, require different threshold values for getting the fault. And this is also a function that is well required. We do have also the digital output that reflect open output, open circuit, if the resistance is higher than 10 kilo ohm, or short when the resistance is lower than 50 ohm. We do have also, this is intrinsic on the DO, but we do have also the contact out for, let's say, detecting the fault via a digital input dedicated. Okay, so we do have a question. I think we have a question. Can I know cost how I can be trained for the workshop? What is the problem? Probably is the thing is for functional safety. Are you asking probably for the functional safety training? We do have a program, and we can, of course, if you send us an email at the end of this presentation, we'll see our email. We can say forward the request to our dedicated office that you will get an answer. Okay, so you want to go, Gabriele, with the power supply?
Yes,
so it was a question from one attendee before.
Another question, if you wanna.
Okay.
Share, let me open it right here.
I think it's more for your area, specific working area than mine.
How and where the dry contact
relay employed in a typical marshalling system cabinet?
It's probably the application we were saying before. I'm not sure if you're referring to that or to the unipolar configuration. I'm not sure. One was the condition where a digital output card has to be put into communication with the digital input card.
Yeah, it's not clear. It's not clear. Maybe
yes, if you
can send an email later on, we'll send you information.
We can provide an
okay. So
in the meantime,
we go ahead with the power supply, which is very, very important in the safety instrumentation. At least we try to explain why it's important.
Yes, that's why we're here. We try. So GMI has various solutions regarding SIL certified power supply systems that can be installed in hazardous area. Before going into the specific operations of the safety power supply system, let's have a brief overview of the products. A power supply system is available in a 7, 9, or 19 inches rack, and it can contain up to 6 power supply modules. Each one of them can provide up to 50 amps. Two of these racks also have a slot for a diagnostic module to monitor the health of the system and the application. All these solutions allow the redundancy of the power supply modules to obtain different working configuration. We also have two standalone 50 and 20 amp solution, which can also be parallel together until together to reach up to 10 modules connected in current sharing bus. So now in the next slide, we can start enjoying a bit more about the concept of safety, why it's very important, and power supplies are nested into this safety concept. This is because the failure of a power supply can cause serious accidents, which can lead to serious consequences in terms of lives, equipment, infrastructure, environment. And for this reason, it's necessary to have safety devices that can guarantee high performance. There are two types of dangerous fault condition that we need to address. The first one is an undefined load voltage in a range between 2 and 20 volts, usually called an undervoltage condition, which must be considered as a dangerous failure. This is because an incorrect power of the load can lead to a reduction of the performance of the load and can cause a premature instrument failure. This problem can be overcome using a redundancy configuration, but it is not always sufficient with the standard device and do not make us immune from possible faults from the power supply itself. A standard power supply system does not consider the common mode faults and the spurious faults that may occur, leading to a production downtime, for example, and the redundancy of the power supply minimize this risk because the common mode failure are considered in the SIL assessment made by the certification body. A second dangerous failure condition of a power supply is when the output voltage exceeds 30 volts. In this condition, the load suffers an overvoltage condition, and this can lead, of course, to a malfunctioning or a complete damage of the load, disrupting the normal operation of your application. We can make, for example, we can talk about an engine cooling system powered by a standard power supply. In case the power supply fails and find itself into one of the two conditions we just mentioned, the cooling system will be damaged, overheating the engine, leading not just to damage the equipment, but also is going to disrupt the plant operation. With the safe power supply system and the proper, of course, redundant configuration, we can guarantee high performance and reliability. So why a safety power supply system is better than a standard one? Let's go to the next slide, please. So a standard power supply is not designed based on the IEC 61508, and the FMEDE evaluation has not been performed. A standard power supply system does not have overvoltage or undervoltage protection, while a safety power supply system have both because it's a requirement in order to get the certificate. A standard power supply can be used in a redundant configuration, but they do not guarantee that our application is safe. When we have to parallel standard power supply, external components such as an O-ring diode is required, which means having additional wiring, which of course affect the power supply itself, leads to voltage drop in the loop. In some cases, it's possible to overcome this issue by adjusting the voltage to compensate the voltage drop, but it's also true that this operation increased the device consumption. A standard power supply has a higher number of spurious faults than a safety power supply doesn't have. The price, of course, is another difference. A standard power supply is usually cheaper than a safety one, but this is because the standard one has components with limited operating range, so the final cost can be kept low. The quality of the internal component affects the lifetime of the device, and the safety power supply use components with better operating range. Considering that often these devices works in harsh environment, this aspect shouldn't be overlooked. So a better design, besides overall better performance, means also that the device can work at a lower stress level with less failure and considerably longer lifetime. So to summarize what we have seen so far, it is important to use a safety power supply because it provides protection against under voltage or over voltage condition, which are both dangerous failures. A safety power supply significantly reduces undetected dangerous fault thanks to an inbuilt diagnostic system. In fact, when an anomalous condition occurs, the output of the power supply goes down to zero, so which represents a safe state. In our power supply, there is also a transistor that, in case of fault, can be used to alert a PLC, so the proper action can be taken. Another advantage of using a safety power supply, as we can see in the next slide, is the presence of the O-ring diode inbuilt in the device. This grants a huge cost advantage as it is not necessary to wire additional external components. GMI power supplies do not require external diodes for parallel configuration because we have an active ideal diode in each of our modules. This increases efficiency, reliability, availability, and reduces the space because beside the external component, the external diode, we also have to consider the wiring and the heatsink that usually is mounted on the external component. In the next slide, just for a moment, we can see a list with the advantages that the ideal diode system, the inbuilt diode system in the safety power supply brings compared to a standard power supply. Next. Thanks. GMI power supply can be paralleled and their internal load current sharing circuit operated to distribute automatically the current load equally to each power supply module to increase the reliability and reduce the power dissipation. As we can see in the next slide, there is an example when we can see 4 of our power supply modules parallel together, where we have 2 AC lines for powering the modules, and then we have 1 output bus for driving the load. The last thing is, which is kind of important, an important feature is called a short circuit proof protection. This system avoids that in the event of a short circuit of one of the loads connected to the power supply system, there is not a complete shutdown. So when our power supply detects a short circuit on the line, it sends a current peak that can reach up to 800 amps for half millisecond. This current peak can interrupt the protection fuse or the circuit breaker associated with the specific load. So it's not going to affect the entire operation and the operation of the other loads.
Okay, thank you, Gabriele. Of course, this is information maybe you never heard about power supply. This is probably first. And we try, of course, the power supply is very significant in the system and must be considered in the SIL calculation. And because power supply is not always a fail-safe device, not really fail-safe. Can be fail-safe, but there are situations where, especially switching power supply, can be really dangerous for the systems. All these things can also apply to. There is a question for chemical industry. Yes, of course. Chemical is required SIL certification, SIL instrumentation. Okay, we almost finished. We can remind you that we have a website with all information and you can download it. Question and answer you already answered. We tried. If not, please write us. Remind you that there is a live webinar schedule on our website. Please stay connected. You can also get information via LinkedIn. You can see all this webinar and the others on our YouTube channel. Okay, so this is also reachable via our website. And we just want to have your feedback how we did it. Please, you can write whatever you like because it's anonymous. Is not, of course, based on your name. So, but it's important for us for improving our communication with the customers. And we like have your your feedback. Yeah, thank you. Just another few seconds, and as long as the words are good, I can close it. Okay, thank you for answering. I'm gonna stop now. Okay, thank you again. We just remind you our contact details if you wanna write us and if you wanna call us, whatever you like. These are our details for more information about safety. Thank you again. Thank you, Gabriele.
Thank you. Thank you for being here. Thank you for listening to us.
And let's keep in touch, and maybe we see you in the next webinar. Thank you.
Thank you.
Bye-bye.
Bye.